Hello. We'll wait for a few minutes. Hello. So good afternoon, everyone. Today we'll start a new point. That is the concept of capacitance. Okay. So screen is visible to all, right? Okay. So capacitance. So all of you know what is capacitance, right? You already studied that. So here, just consider this figure for understanding. Here we are considering the two conductors. Okay. First conductor is M1 and second conductor is M2. Consider two conductors M1 and M2. This conductor M1 is positively charged. Okay, and total charge on this M1 is plus Q, and the conductor M2 is negatively charged. The total charge on this M2 conductor is also Q. Okay, means both are having same magnitude. Both are having same magnitude. Only this M1 is having the positive charge and M2 is having negative charge. So we have to see here what is actually the capacitance. Okay. So and here we are considering that these two conductors are placed in a dielectric material. Okay. So we have to obtain the equation for the capacitance C. So everyone studied the capacitance C, and you know that for the capacitance there are two plates, right? Two conducting plates are there, and in between these two plates there is a dielectric material, right? That is nothing but a capacitor. Okay, so here consider two conducting materials, that is M1 and M2, which are placed in a dielectric medium having permittivity epsilon, right? So here two conductors or conducting materials are there, and in between them there is a dielectric material and it is having permittivity epsilon. Okay, and the material M1 carries positive charge and M2 carries negative charge equal in magnitude. So I told you that this M1 is positively charged and M2 is negatively charged, and both are having the same charge, that is Q, right? That is Q. And there are no other charges present, means no other charges are present in that dielectric material. Okay, only two conductors having positive and negative charge are present. No other charges are present there, and total charge on the system is 0. Okay, means the conductor M1 is having positive charge, M2 is having negative charge, and no any other charge is there. Therefore, total charge means the positive and negative get cancelled there. So the total charge on this of that system is equal to 0. And in conductors, okay, in conductors the charge cannot reside within the conductor, and it resides only on the surface. Remember that when we are considering any conductor that can be of any shape, consider any conductor which is of any shape. So inside that conductor charge will not be there. This is a property of conducting material, that the charges always reside on the surface of that conductor. Okay, charges always reside on the surface of the conductor. So uh, this M1 and M2 having positive charge and negative charge. So on this M1 there is a positive charge plus Q, and on this M2 there is negative charge minus Q, and these charges are on the surface. Okay, are on the surface. So such a system which has two conducting surfaces. Okay, so a system which has two conducting surfaces carrying equal and opposite charges. Okay, so you can imagine the capacitance. It is having the two conducting plates. So one is positively charged and second is negatively charged, right? So these are separated by a dielectric. Okay, and it is called a capacitive system, giving rise to the capacitance. So what is happening when we are considering such a system where the two conductors, one is positively charged, another is negatively charged, and in between them if there is a dielectric material, then it is nothing but a capacitor. Okay, or it gives rise to a capacitance. So the electric field is normal to the conductor surface, and electric flux is directed from M1 towards M2 in such a system. So electric field is normal to the conductor surface, means it is perpendicular to the conductor surface, and electric flux is directed from M1 towards M2. So in this figure, so this electric flux, the direction of electric flux is from M1 to M1 to M2, and electric field intensity. Okay, electric field intensity is perpendicular to this conductor. Okay, it is perpendicular to the conductor. So there exists a potential difference between the two surfaces of M1 and M2. Of course, these are one is positively charged and another is negatively charged. So there will be the potential difference between these two conducting surfaces. So let the potential is V12. Okay, suppose the potential between these two conducting materials is V12, and the ratio of the magnitudes of total charge on any one of the two conductors, uh, and potential difference between the two conductors is called the capacitance, right? So all of you know that this C is equal to Q upon V, or you may have also studied that Q is equal to CV. This is the standard equation. You may have also studied in basic electrical engineering. This Q is equal to CV is general equation. So C is equal to Q divided by V. So here the potential difference between the two conducting plates is, or the two conducting materials is V12. Therefore, C is equal to Q upon V12, or in general we can say that C is equal to Q upon V, where this Q is the charge in coulombs and this V is the potential difference in holes, right? So what is the unit of this capacitance C? Capacitance is measured in What is the
Farads.
unit? Yes, it is measured in farad. And from this formula, what can be the unit? From this formula, can anyone tell me the unit?
Coulomb per volt.
Coulomb per volt. Correct. Okay. So in examination, such questions can be asked. You know the general, that is farad, but from formula it is coulomb per volt. Okay. So 1 farad is equal to 1 coulomb per 1 volt. Okay. Now, as charge Q resides only on the surface of the conductor, it can be obtained from the Gauss law. Okay. So Gauss law is in integral form. Q is equal to closed surface integral of d bar dot ds bar. Means when you are considering any surface, any closed surface, so charge on that surface is given by Q, which is equal to closed surface integral of d bar dot ds bar. And this is Gauss laws. Then what is the relation between d bar and d bar? D bar is equal to epsilon e bar, right? So this Q is equal to closed surface integral of epsilon e bar dot ds bar. Now here again we can write this epsilon as epsilon is equal to epsilon 0 into epsilon r, right? Because this epsilon is the permittivity, but that permittivity is nothing but the permittivity of free space plus relative permittivity, right? So this Q is equal to closed surface integral of epsilon 0 epsilon r into e bar dot ds bar. Now this V is the work done in moving unit positive charge from negative to positive surface and can be obtained as. So we have to now obtain equation for the potential. We know the potential V. V is equal to, what is the formula for V? V is equal to, or what is formula for work done? What is potential V? We have seen in last chapter. This V is equal to W upon Q. This is nothing but the work done. We are considering the 2-point charges. So when we are moving any charge from one point to another point, so whatever be the work done in moving that charge from one point to another point is nothing but the potential. Okay, and it is measured in volts. So also we obtained this equation in second chapter only. So this V is equal to minus line integral of E bar dot dl bar, right? So this is the line integral. So it is equal to minus integration from minus to plus. Okay, so we are moving that charge from minus to plus position or the surface. So it is integration from minus to plus of E bar dot dl bar. Okay, now we have to write equation for capacitance. C is equal to Q upon V. Now Q from the Gauss law. What is the Gauss law? Q is equal to closed surface integral of d bar dot ds bar, and d bar is equal to epsilon E bar dot ds bar. Okay, and this V is equal to minus integration from minus to plus of E bar dot dl bar, and it is in farad. So this is the general equation for the capacitance. For capacitance, now in examination, what they are asking? They are asking the concept of capacitance. That time you have to obtain equation up to this point at least. Then they are asking the capacitance for parallel plate, okay, and for the circular rings, okay. So for both, we are going to see the derivations, and they are asking examples also, okay. Now, so if the charge Q is increased, then E bar and D bar get increased by same factor. Okay, so if we increase the charge Q, then E bar, that is electric field intensity, and D bar, that is electric flux density, also increases with same factor, and the voltage V also increases by same factor. Okay, so thus the ratio of Q to V remains constant at C. Hence the capacitance is not the function of charge, field intensity, flux density, and potential difference. Right. So it is just like a resistance. Okay. What R is equal to this by using Ohm's law, V is equal to IR, but we are taking that R as a constant. Likewise, here this C is considered as constant. Okay, means if you increase the charge Q, with that ratio only you have to increase their V so that your capacitance will remain same. Okay. So this is general equation for the capacitor. Okay. So if in examination, if they are asking you only the concept of capacitance, then you have to write up to this point only. Okay. Now we'll see the next, that is parallel plate capacitor. This derivation is also asked in examination and they are asking examples on this. Okay, this derivation. So everyone concentrate. Now here, parallel plate capacitor. All of you know the parallel plate capacitor, and when you are studying that time also, when you indicate the capacitor, that is also the two plates. You are indicating the two plates only when you write the symbol of the capacitance, right? So from that you can imagine a parallel plate capacitor. So here consider the plate 1. This plate 1 is having the positive charge and plate 2 is having negative charge, right? So here in between them the dielectric material is there, and that material is having permittivity of epsilon. Now the charge density, the surface charge density at this plate 1 is plus rho s because it is positively charged, and the surface charge density at plate 2 is minus rho s as this is negatively charged. Now we can consider this is placed on a z axis only. Z axis only. Okay. Now this plate 1 is in the x and y plane, is in the x and y plane, and this plate 2 is in xy plane, but it is parallel. Okay, because here z is equal to 0 plane. Z is equal to 0 means this plate 1 is placed at the origin. Okay, concentrate. The plate 1 is placed at the origin in x and y plane, where z is equal to 0, where z is equal to 0, and the plate 2 is placed on positive z axis. Plate 2 is placed on positive z axis, means it is with some distance on this z axis, so that this plate 2 is parallel to the xy plane. Okay, parallel to the xy plane. Now, means the z axis is perpendicular here. Remember, z axis is perpendicular. So a parallel plate capacitor is shown in figure here. Now it consists of two parallel metallic plates separated by distance d. Okay, the distance, total distance between these two plates is d. And the space between the plates is filled with dielectric of permittivity epsilon. Okay, means the dielectric material having permittivity epsilon. The plate 1 carries positive charge and is distributed over it with charge density plus rho s, and plate 2 carries negative charge and it is distributed over its surface with density minus rho s. Okay, different charge densities are there, surface charge densities, and plate 1 is placed in z is equal to 0, that is xy plane, right? Z is equal to 0 means it is xy plane, and hence normal to it is z direction, right? Perpendicular, because this is in x and y plane. You can imagine here is x axis, here is y axis, and in x and y plane there is your plate 1, right? And it is at z is equal to 0 means perpendicular axis is z axis only, and plate 2 is placed above that plate only. with distance d. Okay, with distance d means the z is equal to d plane parallel to the xy plane. Okay, so here let capital A is the area of cross section of plates in meter square. Okay, so the total area of cross section of the plates is A and it is in meter square. Therefore, Q is equal to rho S into A. So charge density is nothing but charge per unit area, right? Charge density. If it is volume charge density, then it is charge per unit volume. If it is line charge density, it is charge per unit length. And this is the surface charge density, right? So it is charge per unit area. Okay, so rho S can be given as Q divided by A, or we can write this as Q is equal to rho S into A coulomb. Okay, so this is magnitude of charge on any one plate as charge carried by both is equal in magnitude. Okay, so this is the magnitude of charge on any plate, means any one of the plate, and the charge carried by both is equal in magnitude, because we are considering that charge is only q. Okay, if it is of plate 1 that is positively charged, then we can say that it is plus q. If it is on second plate which is negatively charged, then we can say that it is minus q. But the magnitude is same, just like the dipole we are considering. Okay, they are having same magnitude, separated with same distance from the origin. Only the sign is different. Okay, so like this here, the sign is only different. The magnitude of both is same. Okay. So assuming plate 1 to be infinite sheet of charge, okay, that plate is nothing but one surface, right? So for the surface charge or for the infinite sheet charge, so what is the formula for electric field intensity? What is the formula for electric field intensity? We have seen in first chapter only the concept of electric field intensity, and we derived three equations. One is for the point charge, then for sheet charge, right? For line charge, and fourth one was for a circular ring. So what is the equation for electric field intensity due to infinite sheet charge? Yes, anyone knows that equation? Yes. Okay. So electric field intensity due to infinite sheet charge is given by E1 bar is equal to, or this is E bar is equal to rho S divided by 2 epsilon 0. That equation is already given here. So into unit vector A bar n. This is the normal or perpendicular unit vector. Normal or perpendicular unit vector. Okay. And it is equal to rho s upon 2 epsilon 0 into, now which is the perpendicular unit vector here to the parallel plates? Here, which is the perpendicular vector to this
Z.
parallel plates? Z, right? So the unit vector is a bar z. Remember these equations because electric field, from electric field intensity, that one equation is compulsorily asked in examination. Okay, either she for sheet charge, for line charge, or for circular ring, तिन्ही पैकी एक तरी इक्वेशन असते कंपल्सरी. ओके, डेरिवेशन्स मोठे आहेत पण इझी आहेत, स्टडी करा. ओके, देन the E1 bar is normal at the boundary between conductor and dielectric without any tangential component. So this E1 bar means the electric field intensity is perpendicular to the boundary between conductor and dielectric. So if you consider any plate, so with any plate and the dielectric, this E bar is or E1 bar is perpendicular. Okay, without any tangential component, means only the normal components are present there, no tangential components. Now for plate 1, okay, so consider first plate uh, 1. This is for plate 1. Remember, this is for plate 1. This E1 bar is perpendicular to the conductor and dielectric material. And for plate 2, this E2 bar is equal to minus rho s divided by epsilon into A bar n. Now, the direction of this E2 bar is downwards, right? That is in minus A bar Z direction. Okay. So, for plate 2, it is minus rho is divided by 2 epsilon 0 A bar n and perpendicular unit vector, and we are going in negative z direction, therefore it is minus A bar z, okay, volts per meter. So the total E bar is equal to E1 bar plus C2 bar is equal to rho s divided by 2 epsilon 0 A bar z and plus rho s divided by 2 epsilon into A bar z. Yes, so this 2 and 2, if you add this, 2 and 2 will get cancelled. So this E bar is equal to rho s divided by epsilon 0 into A bar z. Okay. So the potential difference is given by, now we have to write the equation for V. So this V is equal to minus integration from minus to plus of E bar dot dl bar. Now what is E bar? E bar is equal to rho s divided by epsilon into unit vector A bar z dot this dl bar. Now we have to write the equation for this dl bar because here we are taking the unit vector A bar z. Now what is dl bar? Here we are considering the Cartesian coordinate system, right? Okay, so this dl bar is equal to, for Cartesian system, dl bar is equal to dx A bar x plus dy A bar y plus dz A bar z. So if you take the cylindrical system, coordinates are r, phi and z. So according to that, your dl bar will be different. For spherical system, the coordinates are r, theta and phi. So according to that, your dl bar will be different. So every time remember equations for dl bar. So if you remember these equations, you can also write the surface areas, right? Means ds1 bar, ds2 bar, ds3 bar, means by keeping any one as a constant, you can write these equations also. But before that, you should know the differential lengths. Okay. So here, this is dl bar. Now we have to put just this. So V is equal to minus integration from the upper to lower. So the upper is Z is equal to D. Okay, upper plate, the plate 1, the plate 2 is placed at Z is equal to D distance, and plate 1 is placed at Z is equal to 0. So here Z is equal to 0. Okay, means in xy plane at the origin only, and at distance D on Z axis, this plate 2 is placed. Okay. So this is equal to minus integration from Z is equal to D to Z is equal to 0, from upper to lower of this E. So this one, this equation. Now here, dot product, we have to take the dot product here. So A bar Z dot A bar X. What is A bar Z dot A bar X? A bar Z dot A bar X?
0.
0. A bar Z dot A bar Y? 0. Right? And A bar Z dot A bar Z is equal to 1. Okay. So these both terms will become 0. Only a bar z dot a bar z is equal to 1. Therefore, only this dz term will be present there. Okay. समजताय ना? समजताय का? Yes or
Yes,
no?
ma'am. Yes, ma'am. Yes.
हाँ. Okay. So this v is equal to minus integration from z is equal to d to z is equal to 0 of rho s divided by epsilon into this dz, into the dz. Okay. Now we have to just take the integration. Okay. Okay. So it is equal to minus rho s divided by epsilon, that is constant we are taking outside. So it is integration of the dz. dz is only z, right? Z from d to 0. Okay. So it is equal to minus rho s divided by epsilon into bracket, that is 0 minus d. So it is v is equal to minus plus rho s into d divided by epsilon, and this potential is measured in volts. Okay. Now the equation for capacitance C is equal to Q divided by V, and this Q, we know that at first only we have seen this Q is equal to rho s into A, as we are considering the parallel plates. Plates means these are the sheets. That's why we are considering rho s, right? So it is equal to rho s into A divided by potential formula is rho s into D divided by epsilon, right? So just solve this rho s into A into epsilon divided by rho s into d. So rho s and rho s will cancel, and it will be only epsilon A divided by d farad. Now this epsilon is nothing but epsilon 0 into epsilon r, right? So the capacitance C is equal to epsilon 0 epsilon r into A divided by d. Okay. समजलं हे इक्वेशन सगळ्यांना? This equation is asked in examination. Okay. And they are asking examples on this. And in GATE examination also, there are questions on this capacitance. So everybody understand this capacitance. Okay. Very easy. If you go through at least 1 or 2 times only, you will understand. So first concentrate in lectures so that you will understand how the terms are coming. Okay. समजले? Can I take the next point?
Yes, ma'am. Go to next.
Okay. Pratiksha, Snehal.
Yes, ma'am.
Okay. Deepak Vibhute. Okay.
येस मॅम.
समजलंय का?
नाही मॅडम, मी आता जॉईन झालो थोडा वेळ.
Okay. Now the next point is the spherical capacitor. Means there are different types of capacitors. So the previous one we have seen is the general, that is the parallel plate capacitor, right? So this is a spherical capacitor. Okay. Now here we are considering the two plates, okay, which are in sphere shape. Okay, this first conducting plate is having radius A. Okay, this plate is having radius A, and the second spherical plate is having the radius B. Okay, having radius B. Again, this one, the inner one is positively charged, and this outer one is negatively charged. Outer one is negatively charged. Both are having same charges, but positive and negative. Okay. And dielectric material is there with permittivity epsilon. Okay. Remember, in magnetic circuit, there is a permeability, that is mu, and in electric field, there is a permittivity which is epsilon. Okay, so remember that difference. Now here you just concentrate or just remember this figure. Okay, consider a spherical capacitor form of two concentric spherical conducting shells of radius A and B. So outer sphere is B and inner sphere is A, means B is greater than A. Okay. Now, the region between two spheres is filled with a dielectric of permittivity epsilon, and the inner sphere is given a positive charge and the outer with negative charge minus Q. Okay. Now we are considering here a Gaussian surface as a sphere of radius R. It can be obtained that E bar in the radial direction and is given by. Okay, so here what we are considering, we are considering a Gaussian surface. Okay, Gaussian surface means what? Gaussian surface means what? If you have studied, what are the properties of Gaussian surface? So it is a surface, okay, closed surface, and there are different charges, and these charges are directed in outward direction. Okay, these are directed in the outward direction. We are considering that as a Gaussian surface, means the Gauss law is applicable to such surfaces. Okay, Gauss law is applicable to such surfaces. Okay, so when that E bar means electric field intensity is in outward direction. We have seen in the second chapter only the concept of this electric field intensity. We are considering one charge, and that charge is producing electric field, and that is in the outward direction, right? So when we are considering one more charge, that is the test charge, and when we are moving that test charge around the first charge, what is happening, that charge is experiencing some force, okay, with some intensity, and according to that only we obtain the formula of this E bar. So this E bar is equal to Q upon 4 pi epsilon 0 R square into A bar R. This is basic formula. I think everybody knows this at least. Okay. So now the potential difference is the work done. Alright, we have seen in moving unit positive charge against the direction of E bar. That is from R is equal to B to R is equal to A. So what I told you, we are considering a test charge QT. Actually here I cannot draw something. No pen is there. So this is just a highlighter thing is there. Okay. Okay, no problem. I hope everybody can remember. We are considering here, just concentrate on my pointer here. We are considering here one point charge. Okay, plus Q. Then whatever be the electric field developed by that charge is
Madam.
in outward direction. Hi, yes.
ते रिसायकल बिनचं चिन्ह आहे ना त्या शेजारी बघा बरं पेन आणि पेपर दाखवले इकडे
Recycle bin.
डिलीटचं चिन्ह राईट साइडला डिलीटचं चिन्ह नाही का इकडे एकदम त्या शेजारी पलीकडचं
हे का? हे का?
हम्म.
एडिट टेक्स्ट नाही ना, ते ऑनलाईन काहीतरी दाखवते. एडिट PDF. Okay, but just imagine here, I'll tell you, because I already explained that concept. Just concentrate. Consider one charge plus Q, okay, and it is producing its electric field in outward direction. Now, if I consider one more charge, that is test charge QT, okay, and if I move that charge around this first charge, then what happens? That second charge, that is test charge, experiencing some force, okay, एक्सपिरियन्सिंग सम फोर्स. एखादा चार्ज आधीच प्लेस केला आणि दुसरा जर चार्ज त्याच्या जवळ आणला तर काय होणार आहे, आधीचा चार्ज काहीतरी त्या पुढच्या चार्ज वरती फोर्स एक्झर्ट करणार आहे, बरोबर ना. ओके, म्हणजे जर त्या दुसऱ्या चार्जला तर पहिल्या चार्जच्या जवळ यायचं असेल तर काय करावं लागेल, तर त्याला त्याचं जे काही फोर्स आहे त्याच्या अपोजिट डिरेक्शन मध्ये त्याला काहीतरी फोर्स अप्लाय करावा लागणार आहे, बरोबर ना. फॉर एक्झाम्पल, इफ यू कन्सिडर वन मॅग्नेट, ओके, two same poles, when you are considering that time they are opposing, then if you want to make these two poles close, then what you are doing, समजते ना. जर मॅग्नेट कन्सिडर करा, एक पॉझिटिव्ह मीन्स एक एन पोल आहे, एक यस पोल आहे, तर काय होणार आहे, अट्रॅक्ट होणार. पण दोन्ही जर यस असतील तर अट्रॅक्ट होतात का, होतात का, नाही, रिपेल होतात ना. मग जर तरी पण तुम्हाला जवळ करायचे असतील ते दोन्ही पोल्स, जर सपोज कनेक्ट करायचे असतील तर तुम्ही काय करता, काय करता, त्यासाठी फोर्स अप्लाय करता, बरोबर, फोर्स अप्लाय करता आणि काय करता, ते कनेक्ट करता. त्यासाठी तुम्ही काहीतरी वर्क करता का. येस, आर यू डुईंग एनी वर्क ऑर नॉट. हॅलो, हॅलो, एम आय गेटिंग, hello, yes, anyone reply me.
Yes, ma'am, but your force is nothing but work.
Force, yes, means here I want to just tell you the concept of the potential here. That potential means that force means what you are saying, I don't understand the question actually. That force I'm applying means I'm doing some work, right. Here I'm doing some work, okay. So similarly here also you are doing the work, right. पण त्यात जर तुमचे यस पोल आणि एन पोल असतील तर ते कनेक्ट करण्यासाठी तुम्हाला काही फोर्स अप्लाय करण्याची गरज नाही, तिथे तुम्ही काहीच वर्क करत नाही, ते ऑटोमॅटिकली कनेक्ट होतात, ओके. सो लाईकवाईज हिअर ऑल्सो, if you want to move the second charge in direction of the first charge, you have to do some work, okay, you have to do some work. So here the potential difference is the work done, means we know the definition of potential, that is nothing but W upon Q, means we are doing some work for moving one charge from one place to another place, right. So here we are moving a unit positive charge against the direction of this E bar here, right. That is we are moving from R is equal to B to R is equal to A, right. Means from the outer sphere to the inner sphere, okay. So the potential V is equal to integration from minus to plus of this E bar dot dl bar. This formula we already seen in the second chapter. You go through the potential concept there. We have seen potential gradient, right. And it is equal to integration minus integration from. Now this R is equal to B because the minus, you can see here, this minus charge is on the outer sphere, right. So that is at having radius B. So it is from R is equal to B to R is equal to A of this E bar dot dl bar. Now E bar is equal to Q upon 4 pi epsilon into R square into unit vector A bar R dot dl bar. Now we have to write equation for this dl bar also, okay. Now this dl bar is equal to here we are considering a sphere. So can anyone tell me what will be the dl bar, the total dl bar here for the spherical system? Here it is given dl bar is equal to dr into a bar r, but here it is only for this term. Can anyone tell me what is dl bar in spherical coordinate system? The coordinates are r, theta, and phi. If the coordinates are r, theta, and phi, what will be the dl bar in spherical system? Yes. Okay. So if we are considering spherical coordinate system, then this dl bar is equal to r square sine theta. Okay, remember r square sine theta, dr, d theta, d phi. Okay, it is for the spherical coordinate system. Now, here we are considering only the r, which is only a simple length, that is not any angle. That's why this dl bar is equal to dr into a bar r, and here a bar r dot, if we take the dot product with a bar phi or a bar theta, it becomes 0. Okay, it becomes 0. Therefore, this dl bar is equal to dr into a bar r only. Okay, so this v is equal to minus integration from r is equal to b to r is equal to a of q divided by 4 pi epsilon 0 r square into unit vector a bar r dot this dl bar, that is dr into a bar r. Now a bar r dot a bar r is equal to 1.
1.
Therefore, right. So it is equal to minus integration from r is equal to b to r is equal to a of q divided by 4 pi epsilon 0 r square into dr. Okay, now the variable is here r, right? So it is dr divided by r square. So take this term outside, that is q upon 4 pi epsilon 0 is as a constant. So it is equal to minus q upon 4 pi epsilon 0 outside into integration of this dr upon r square. So I'm taking this in the denominator. So it is r raised to minus 2 from b to b to a into this dr. Okay, so it is equal to minus q upon 4 pi epsilon 0. Actually, this should be here r raised to minus 2 into dr, and integration sign should be same as it is. Okay, so this is by mistake. So it is equal to minus q upon 4 pi epsilon 0, and the integration is r raised to minus 2. Here we are adding plus 1 and divided by minus 2 plus 1 from a to b. So just to solve this, so it is minus q upon 4 pi epsilon 0 r raised to minus 1 divided by minus 1, that is minus 1 divided by r. It will be there from a to b, and minus minus will become plus. So it is q upon 4 pi epsilon 0 1 divided by plus r from a to b. So just put the limits, upper limit and lower, that is q upon 4 pi epsilon 0 1 upon a minus 1 upon b. Now here we are getting equation for v. Now the equation for q, because we have to write equation for the capacitance c, and this c is equal to q divided by v, right? So this capacitance c is equal to q divided by v. So it is plus q divided by q upon 4 pi epsilon 0 into bracket 1 upon a minus 1 upon b. So the general equation becomes this q and q get cancelled here. So for the capacitance c is equal to 4 pi epsilon divided by 1 upon a minus 1 upon b farad. Now this equation is also asked in examination. So everybody prepare for that. They can ask you as a MCQ also question. And on spherical, there is one question. Okay, in GATE also they are asking. So for both types of capacitance, the equations are different. Okay, equations are different. And here we are considering the coordinate systems. That's why whatever you have studied, or if you take the reference of any other electronics or any other book, the equations will be different, because here we are considering the systems, different coordinate systems, and according to that we find here. Okay, now write down this example. And one more thing, I uploaded all tutorials on Drive. Okay, I think in last week only I uploaded. You start writing all tutorials, because 6 tutorials are compulsory to all for the submission. Okay, so everybody solve the tutorials, given tutorials. Okay, because you are having 25 marks for ICA. Okay, and your submission will have some marks. Okay, that's why everybody start writing, because at last you will become overloaded. That's why I'm giving from now only. So everybody complete these tutorials. I think 2 chapters notes are uploaded on Drive. I'll upload the 3rd chapter notes also. Okay, today only I will upload, so you can complete minimum 3 tutorials at least, and no more questions. Okay, so don't worry about that, but complete it correctly. Don't write anything, don't copy and paste. You just first understand and then write the things. Otherwise, only copy and pasting and only blackening the pages is not the way. Okay, because whatever question papers or IC papers I have seen, so I'm not satisfied from your result. You simply cannot copy and paste. That's why I'm saying you just understand first the concepts. EME is not that much easy. If you are, and how much examples I can take? Okay, because EME is too vast. We are still in the 3rd chapter only. We are having 3 chapters more. Okay, I know that will not take that much time like first section, but we are still having 3 pending chapters. Syllabus is too vast. If I am taking examples, and if your response is very low, then what I can do here? Okay, so you have to practice more and more problems. You can refer the internet, you can refer books. Okay, so you just solve. At least you read whatever given in notes and examples. You can practice from that also. So you just cannot transform any vector. I'm simply disappointed from you. You have to study very hard for this EME. And don't take it easily, because last year this PS3 subject, for PS3 subject, everyone taken that subject as easy. But many students having backlog for that. So we cannot say which paper will be of which type. And Google, if it is an online examination, Google cannot always give you the answers. Okay, so examiners are also knowing that you are copying from Google, right? They also know. So they are putting now the new questions which are not available at Google. So you study, that will be better for your future also, right? Okay, so if everyone have noted the example, just concentrate here. So what is given? Let epsilon r1. So what is epsilon here? What is epsilon? So these basic concepts you don't know. and number of derivations are there. And you are lucky that the exam is online. So if it is offline, then you have to study very hard. Okay, so everybody prepare for this. Don't take not this subject, but any subject don't take easily. Okay. So let this epsilon r1 is equal to 2.5 for 0 is less than equal to y is less than equal to 1. Okay, epsilon r2, all these are the permittivities. Epsilon r2 is equal to 4 for 1 is less than equal to y is less than equal to 3 mm. Okay, 0 to 1 mm साठी epsilon r1 किती आहे 2.5. 1 to 3 mm साठी epsilon r2 किती आहे 4. Okay, and epsilon r3 for 3 to 5. Okay, means y will vary from 3 to 5. That time this epsilon r3 is equal to we have to find here, I think. Okay, so epsilon r3 for 3 is less than equal to y is less than equal to 5 mm. Conducting surfaces are at y is equal to 0 mm. Okay, and y is equal to 5 mm. Okay, so here 3 surfaces are in between y is equal to 0 to y is equal to 5. Calculate capacitance per meter square area if capacitance per meter square area we have to find. Not only capacitance, C upon A we have to find. If epsilon r3 is that for air. Okay, now for air we have to find, and second condition is epsilon r3 is equal to epsilon r1, that is 2.5. So first we have to consider this figure according to given data. So here x-axis is there, y-axis is there. Okay, x and y-axis. Now here this y is varying from 0 to 5. Okay, y is varying from 0 to 5, that is from origin to here 5. Okay, capacitor is there. Now from 0 to 1, okay, 0 to 1, here this is distance 1, that is d1 is equal to 1 mm here, 1 mm. Then for this d1 epsilon r1 is equal to 2.5. Then from 1 to 3, okay, from 1 to 3, here this is up to this point it is 1, up to this point it is 3, means it is 1 to 3, 1 to 3, the second layer is here, and that distance d2 is equal to 2, right? From 0 to 1 it is 1 mm total. From 1 to 3 it is 2 mm, and third layer is from 3 to 5. Okay, so here it is 3 and last is 5. So from 3 to 5 total distance d3 is equal to 2 mm. Okay, is equal to 2 mm, and we have to find the capacitance. Okay, so just take the formula, because here it is a parallel plate capacitor. So this C is equal to epsilon 0 epsilon r into A divided by D. From this, just check whether you are able to solve this or not. Okay, so we'll see the remaining part in next lecture, and tomorrow we'll finish our third chapter. Okay, so and everybody start writing the tutorials. At the end, I'm not going to see listen any answer from you, because you are having the ICMRs for that. Okay, so for today we'll end here. Try this example. Formula is already given. Thank you all and have a nice day. Thank you.